Good afternoon, everyone, and thank you for attending our Tachyon 100G PCB Performance Attributes and Applications webinar. My name is Brian Nolan. I'm the Senior Vice President here at EPIC. Before we get started, I just want you all know that you will be muted during the presentation, and we will not be doing a live Q&A during this webinar. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel, and we'll be sure to follow up with you as soon as the webinar is ended. Also, we will be recording this webinar, and we'll be posting the recording and the slide deck on our website and our YouTube channel. Our presenter today is Michael Gay, Director of High Performance Products at Isola. Michael has been with Isola for 24 years this coming June, and has 29 years of experience in laminate materials and PCB manufacturing industry. He has held various positions at Isola, which include Technical Sales Manager and Director, Emerging Products Asia Pacific region, where his responsibilities range from managing the entire NPI and technical service staff in Asia, new product production process, PCB process development, product development, technical support, and troubleshooting for Isola customers. Since returning from his role in Asia, he has worked closely with major industry OEMs to develop and qualify Isola materials for next generation technology. In his current position, he provides product application training, collaborative design support, design reviews for selecting materials across a wide range of applications, including high-speed digital, high energy voltage, CAF resistance, RF and MW. Michael is also active in various PCB industry organizations where he provides technical expertise to industry critical committees and projects. He received his Bachelor of Science in Mechanical Engineering and Master of Business Administration degrees from Portland State University. So, without further ado, I will pass this over to Michael.
Thank you very much, Brian. I appreciate the introduction. Thank you all for joining today. We're going to be discussing our product, Tachyon 100G. It is an ultra-low loss, lead-free compatible material. It is halogenated, but it is PFOS-free, or if you want to keep the P silent, of phos-free. Anyway, the product is used in applications, in high-speed digital applications, and also RF microwave applications. So with that said, let's go ahead and get started. First, just give a little bit of information about our company and our commitments to our industry partners. We've been making products in the industry for over 100 years as a company. In 2012, we reached our 100-year anniversary, and so we've been going along as a company. Started manufacturing materials for printed circuit boards in 1956, and so we started out with like a bakelite product, and moved into FR4 products in the 60s, late 60s. And then since then, we've developed all kinds of different resin systems over the years, which I've been privileged to work with Isola and bring out to the industry for all kinds of different applications. Our commitment to our customers is product consistency, long-term reliability, processability at the PCB fabricator, and then the ability to take our materials and apply those to specific requirements or specific applications. And if there wasn't a product available, we would try to develop a product that would give you the ability to manufacture to meet those specific needs. This is our product profile. As you can see, there's a lot of new products that have been introduced by Isola in the last couple of years with regard to our product portfolio. We have a lot of new halogen-free products that have been introduced or will be introduced here in the very near future. The most recent addition to our product offering is the Tachyon 400G product. We've also introduced at the first of the year IS580G, which is a halogen-free product, which we have, and also the IS550H, which is halogen-free. So we're kind of focusing on the halogen-free. It gives us a better thermal reliability product. Tachyon 100G was began development in around 2014. We had it fully launched in 2017, and since then the product has grown pretty well over those last several years. And we've got quite a few applications, all different types of applications, from military applications to just standard, server router types of applications for various OEMs. So these common applications by the markets that we work in, these applications are all different types for wired telecom and computing and high-speed digital. You can see the different types of applications that people might use this for. Mid planes, back planes, line cards, PCIe 5, 6 servers, AI computing, high-speed switches, high-end routers, video collaboration. All those types of systems, Tachyon 100G has got some applications being used for that. For wireless telecommunications in the RF microwave market, you would think that this product, although it was developed for high-speed digital, wouldn't necessarily go into this market, but these types of applications, and in particular phased arrays, are pretty common applications. At this moment, there's probably over 10,000 21 by 24 format sized Tachyon 100G with a hybrid of 370HR floating over your head in low Earth orbit. That application is probably the largest application of all of them for Tachyon 100G. So from a capability standpoint, that might tell you, oh, the material will handle thermal cycling pretty well because it's going into an environment where it's going to see sunlight, no sunlight, sunlight, no sunlight on a pretty frequent basis. So it sees a lot of thermal cycling from that exposure in that low Earth orbit environment. So we see it going into satellite communications, going into military communications and infrastructure in the US here quite often. Also in the automotive industry, where you need the higher speed signaling and the high reliability in the V2X, which is now becoming more important, which is the vehicle to everything applications. There is a large OEM that's looking at how we use Tachyon 100G to go into the roadside communication equipment that's going to be necessary to interact with all of the vehicles in the high density, high traffic areas for fully autonomous driving. The idea is that you're going to need high computing power roadside so that you can make sure that all the cars know how to communicate with each other. And so not just vision systems and things like that, but also how do I talk to each other so that we have everybody in communication with everybody with regard to the types of cars that are going to be on the road. So the product offering and the property summary, so we'll go through that. The product comes with a range of thicknesses from 2 mils all the way up to 20 mils. We have been working on thinner dielectrics like 1017 and 1027 glass. We started to do some sampling on that. So if you need a thinner dielectric for an application, we can talk about that. This product was optimized in the constructions that were offered to allow us to have really excellent lead-free assembly performance, as well as excellent thickness control, because of the way that the resin system and the combination of glass and resin is assembled for this product. We used low decay glass for this. Most products use the E-glass. This uses a low decay glass. It gives you a significant improvement in your dielectric constant, but it also improves your loss. A lot of people don't understand that low decay glass is also lower loss glass as well. So that gives us a benefit there. We use high performance copper, which reduces the conductor losses. So your total loss is reduced by using a combination of the low decay glass, the lower loss resin system, and the low loss high performance copper. The current standard copper we use is what we've called VLP2, or the industry kind of is moving towards HVLP with a generational number. So it'll be HVLP, HVLP2, HVLP3, et cetera, where you're looking at the next generation of foils, for the 224 gigabit per second systems being in the range of what they would call HVLP4 or HVLP5, which are generations of copper that have been developed by our suppliers. We've also qualified what we call an advanced RTF copper foil. This is about a 2.3 micron surface against the laminate. And when we talk about roughness, please keep in mind that we're talking about only the surface that's in contact with the laminate. The PCB fabricator is responsible for the other 3 surfaces that are treated for bonding on the transmission lines that are on your design. We've also qualified an HVLP3 copper, which is a 1 micron roughness against the laminate. So those are also available, but the standard is a 2 micron. That's the one that we sell in high volume to our customers. As far as the glass is concerned, we offer a square weave, mechanically spread glass, and that's the general direction the industry has been going because you want something that's consistent in both directions. When you're laying your transmission lines down, you want the weaves to be as consistent as possible in both directions. They're not perfect, but that's the idea behind it. This product uses 1035, 1078, 1067, 1086, and 3313. We do have some 2116 offering in there. I apologize, I didn't put that in there, but we also have some of those weaves that are available with various resin contents that are provided in the online. If you want to go to the product offering page for Tachyon 100G on our website, you can scroll down and click on the constructions tab, and you can find everything that we have to offer there. The square weave and mechanically spread glass, that is a standard. The mechanically spread is a standard for almost every glass supplier in the world right now. All of the suppliers that produce glass, like TGI, Nanya, Asahi, Nitobo, all of those suppliers of glass now spread their glass in using one method or another, because that's the direction the industry pushed to go. And so now that's something to keep in mind. It reduces the fiber weave effect, obviously, by spreading it and flattening out the glass, and it reduces the skew and micro decay effects. Also improves the cap performance because it improves the wet out of the resin on the glass fibers themselves. The product is UL approved, 130 MOT, 94 V0, but this product has been tested by some of our customers at temperatures well above 130 MOT. So if there's an application that is going to run hotter than 130, we do have some information that we can share on that. But if it's when it's UL marked at the PCB fabricator, you're going to see a 130 MOT rating. The product has it's an ultra low loss. The nominal loss on the material is a DF of about 0021, but we do have a range of those. So each glass style and resin content has a different value. So please keep that in mind. It's a very low decay of 3.02, but the range is up to about 3.25, and I'll share that in a little bit. The designs are basically for our 40 gigabits per second backplane and line card designs. High-speed digital, like a 56G PAM4 application. It says beyond, again, it's going to depend on the design, what you can do with the length of your transmission line. So obviously it's always design dependent. The material is a high TG at 200C with a TD of 360, very thermally robust for fine pitch applications. It has HDI capability to 10X. We have a design that was built at 9X that was tested by one of our customers and passed their testing. As far as processing, you can use your standard FR4 process equipment. You don't have to use any special plasma chamber processing to get this material to stick like you would for a Teflon. There's no special drilling equipment, nothing special, just the standard FR4 process equipment. You can use this material in hybrid stack-ups. We have applications with 170 or 370 HR, 185 HR, iSpeed. iTerra is the same resin system, and so those two products can go together easily if you're looking for that, as well as Astra MT77 have been combined with these products. So it really depends on what you need for your signal layers, as far as moving your signals around, what kind of speeds you need. If it's low speed, you can use the FR4s like 185 HR and 370 HR, or you could use iTerra, or even make a whole stack up with the Tachyon 100G. As far as storage, there's no special refrigeration or special handling that's required. The material is shipped in a moisture barrier bag, so you can just reseal the bag and store it in the standard storage location, and you can store it without any tackiness. We have high resin content prepregs that are available for heavy copper applications, so you don't need any high pressure on there. And so those heavy high resin content prepregs can store without any tackiness problem. These have consistent thickness control across the panel. Obviously, the whole prepreg product was well designed so that you have options that will allow you to make a design that is going to work your first spin. The product has excellent CAF performance. We passed on an MRT7, which is more recent. I apologize, I only have 20 mil data in here. If anybody's interested in the 16 mil data on the MRT test vehicle, happy to share that with you. On that's whole wall to whole wall testing. We have a MRT7 Plus design, which also does plane to plane. Reason for that is because as higher voltages are applied to your design, the plane to plane, Z-axis CAF becomes more of an issue. And so we are testing that in our designs now as well. We have solid thermal cycling performance data. We've seen the decoupon design, which is a 4+N+4 stack up, which is a standard like a test vehicle. There's one in here in this presentation that shows a design from Raytheon that we ran with one of our PCB fabricators. And then this has stacked, staggered, and overburied in the design. And the customer tested these up to 9x, as well as up to 24 cycles on the OM testing. It has excellent thermal stability during PCB fabrication. It has a really short press cycle, so that reduces your pressing cost. It says 60 to 80 minutes. It really depends on the temperatures that you use. You could put it in a 60-minute press cycle at 200C and get the material to be fully cured. The cure mechanism is different than you would see on a typical FR4 epoxy, so it gives you flexibility. And because of that, you can actually press this in a combined press cycle, right? So you can take 370HR with prepreg in the stack up and Tachyon 100G with the Tachyon 100G prepreg. You can put that in a single PCB stack up into your press together and run the 370HR stack up and cure the material adequately in that stack up. So that gives you the ability not to have to worry about creating a subassembly and then bonding those two subassemblies together, which increases the cost and reduces the overall process capability of the whole system that you're building. So that's a benefit of this type of material as well. It's easy to combine a press cycle, and it also survives multiple lamination cycles. So your HDI or microvia designs, this product is very robust, and the properties of the material remain even after heating it up and cooling it down multiple times. As far as drilling is concerned, it drills really easy. I have a couple of images that you can see in the presentation. Of course, we don't have a whole bunch of pictures in here, but if you're interested, there's other pictures that we can share. We have hundreds of them that we've done in our testing, and I'll show you the kind of testing that we typically do. Consistent quality and mechanical drilled plated through holes, laser defined through holes as well. You don't require plasma desmear, but when you get to those high aspect ratios in your PCB fabrication process, you'll want to make sure that you have a process that completely cleans out any contamination, any smear, any debris in the hole. And so plasma may be an option that needs to be done on the material given a high aspect ratio. Isola manufactures this material globally. I guess you could put this in pretty much any region and develop it. But really most importantly, I think for the group that we're presenting at EPIC, we're talking about US productivity. So currently we do press in Chandler, Arizona using B stage that's manufactured in Taoyuan, Taiwan. So that's over on the right-hand side in the corner. It's in Taoyuan, Taiwan, and it's two brand new treaters are in that facility to manufacture this material. So they are state-of-the-art with AOI equipment that can see contamination defects down to below 2 mils maximum. So it goes beyond the typical visual inspection that has been in place in history. And so those two pieces of equipment are capable of building this material. We bring that into our Chandler facility and laminate that. As a capability for second sourcing or continuity of supply, we also make the material in Düren, Germany. We can treat and press that material there as well. So if there's any geopolitical problems that occur in Asia, we have a second location that we can treat and process that material, and then bring that B stage into the Arizona location to manufacture. Ridgway, South Carolina, there is a plan to update the pressing equipment to be able to manufacture that material at that facility as well. So those plans are still in the works, so it's not yet capable and ready to go. As far as competitive products, now this is not to disparage anybody's product that's out there. What we're going to do is just talk about how they compare and how we can focus on using Tachyon 100G to cover a wide range of applications that would be able to reduce the inventories at the PCB fabricator so that you can cover the wide range of applications and really focus and define your process at the board shop so that you can make all these different types of applications and prototypes and quick turn applications more rapidly with consistent results because you're working with a single material across a range of different designs. So this is a comparison. We've been asked to compare the Megtron products to the Tachyon and the meter wave product to the Tachyon. So this is the data sheet comparison. Now this is very generic information. It doesn't go through all the details of what these materials are capable of doing. So the most important aspect in the design, at least in my opinion, we'll say that all of these products have great thermal capabilities and process capabilities in that regard. So you could say that these materials are equivalent in that area. So from a PCB fabrication standpoint, what's important is, will my material process without defect? Will my material go through assembly without defect? And that's really the thermal aspect of the material. So Tachyon 100G has very good thermal performance attributes. So that leads us next to the electrical performance attributes. And as you can see, comparing these materials, they're as good or better with regard to the decay. It has lower decay across the range. It's very comparable to Megtron 7 in that regard. And then with regard to the loss, you can see the loss performance characteristics are very similar to the Megtron and meteor wave products. Okay, so very comparable. If you're looking at substitution, so if you want to substitute Tachyon 100G as an HSD product, you can take a look at, say, Megtron 6. Tachyon 100G is going to have better than very low loss performance. The reason is Megtron 6G is an E-glass version, and as I have stated earlier, that product, the E-glass is going to have a higher decay. It's around 6.6, so that increases the composite decay. Whereas the Tachyon 100G, the decay of the glass is about 4.8, so that reduces the overall composite decay. And the same thing with the DF, the loss of the E-glass, or the DF of the E-glass is higher, and so that reduces the overall decay and reduces the DF of the material, comparing it to Megtron 6. And we also use HVLP, which is similar to what the Megtron 6 product uses as well. So very comparable, just better electrical performance overall. If you're comparing to the Megtron 7, it's got essentially the same ultra low loss performance level. The constructions are available are very much the same if you're looking at 1035, 1067, and 1078, which are the most common construction elements for glass weaves. We have an availability of even lower loss advanced RTF copper and HVLP3 copper, as I mentioned earlier, to match the competitive products, because I believe Megtron 7 is typically shipped with an HVLP2 or 3 type of product. And our products are globally available. We have many, like I mentioned, manufacturing in each region in the world where the volume manufacturing of PCBs are. If you look at the laminate comparison, very similar statement here. We're not disparaging. The Rogers products are very good products, but we believe that the Tachyon 100G is a great substitute where you want a quick turn, where you need something you're familiar with that will work and is known to work. and your PCB shop can make comparisons and say, hey, this will drop into your application with not too much variation in the overall performance. Now, with the 4350B and 4003C, you can see that the decay values are a little bit higher than ours. You can get a 20 mil core and a 10 mil core with a 3.25 decay. If you absolutely must have these 3.48 and 3.38 decays, Isola makes an Itera MT40 in this range that can be mixed and matched with the Tachyon 100G. So you could use the Itera to achieve the decay on your RF layers. And if you need high-speed signaling with the Tachyon 100G, you could use Tachyon 100G in your application for the high-speed signaling portion of the board. As far as the losses are concerned, you can see the loss range again is about the same. Again, this is a data sheet comparison, so the data sheet comparisons are only what you can find online. So, okay. If you're substituting, the Tachyon 100G gives you great flexibility. As I mentioned earlier, you have a 2 mil to 20 mil range of this product, and so that gives you the ability to actually adjust your decay. Maybe you don't want to be stuck with a 3.38 decay. Maybe you want a little bit lower decay. You can pick a thickness and target a decay range that you need for your RF portion of your board. The other thing too, it's really interesting. One of the things in the industry that has changed is the products that are being developed in today's market by laminators in the world are more highly filled products. And one of the benefits of high filler content in a product is that you get a better thickness control because that filler kind of stands off that copper from the glass and gives you a more consistent thickness control. And with thickness control, you get decay control. The decay is a function of the resin content in the region of the PCB where that resin content to glass, that resin to glass ratio produces a resin content that results in a specific decay. When you're talking about filled materials, that decay is going to be very consistent. And that's something that testing has been done in the past where you're testing the RF microwave materials and there's surrogates for thin materials that you can do. You have to stack up a 20 mil core to test that. And so one of the things about Tachyon 100G is that it's a consistently performing decay for each of the thicknesses because of that ability to maintain that thickness across the entire panel of the material. So when you're substituting, you can have confidence that you're going to have a decay that meets that requirement. You'll be able to design that product to meet that need. As far as the complement of prepregs, this is one of the things that is really important is that Tachyon 100G has a range of prepregs. You don't have to take that single core material and then match it with another type of resin to be able to make your RF board. You can also mix and match this product with the FR4s, as I mentioned earlier. HVLP2 copper or HVLP copper. Again, FR4 equipment, no special processing. When you get to the RO3003 product, that's a great product, but there's a couple of drawbacks to using a PTFE material, right? So number one, it's got PFAS in it. Number two, it requires special processing because you're going to have to put that in a plasma chamber to prep the surface so you can do plating. You're going to have to put in a plasma chamber before you laminate to make the prepreg stick to those cores with that material. You're going to have to use special drilling processes. And then the copper on that material, unless you buy a low pro copper, which has a resin coating on the copper and requires a different UL, of course, you have a tooth profile that's pretty rough to get a mechanical bond between the PTFE and the resin. So what does that mean? Well, if you take our Tachyon 100G with the HVLP copper on there, and you compare the two products from a loss standpoint, from a total loss standpoint, even though the PTFE is a lower loss resin, the combination of resin and glass and copper of the Tachyon 100G results in a performance level very similar to the RO3003 with standard copper on. So that gives you a benefit where you don't have to spend as much money on the PTFE based material compared to the Tachyon 100G. The other part is the ease of hybrid stackups. You don't have to worry about CTE mismatches. When you're doing Tachyon 100G and you're matching that up with an FR4, you're going to get very similar XY CTEs on the material, so that makes things a lot easier. Again, globally available product in US, Europe, and Asia. So let's talk about the electrical performance. The electrical performance of the material, we've done all kinds of different testing on this material. We've done testing for RF applications. We've done testing for digital applications. So a lot of the testing that we do is both strip line and we do microstrip, strip line, and differential pair testing on the material. We've done quite a bit of it across, and I'll share some of that data with you. This is an older Delta L stack up that we have done and run testing on. You can see the structures and how they were tested. Back to this is a Delta L stack up and cross-section examples that we used for the application for testing both microstrip and strip line performance levels. You can see the stack up here. This is basically an Intel structure that was used for testing. These are the results of this testing. You can see they're up to the 12.89 gigahertz, which is basically the PCIe 4 or 5, I believe it is. This test vehicle was run, I believe, in Asia, in the Taiwan area, and they shared these results with us. This is another test that was performed on material SI performance characterization by TPCA. This was done back in around 2017 timeframe. There were 3 materials that we discussed earlier on the high-speed digital, where you were looking at the various performance attributes, and this is electrical performance based at 12.89 gigahertz, comparing 3 different board shops results, and you can see the little whisker plots here that show how those results varied amongst the different PCB suppliers, but also that the Megtron 7N and the Tachyon 100G are virtually identical products. And you can see that the Megtron 6, between the Megtron 6 and the Megtron 7, you can see what the difference in the E-glass performance does for the material as far as overall loss is concerned. Moving on to the next thing, this is some internal testing. This is an 8-layer Delta L SITV that Isola had produced and ran internally. We also looked at different coppers. So we had 2 different copper types that we put in this testing. You can see we had different line widths and different spacings for the single-ended and differential pairs that were tested on this. We had 14 and 0.6 inch long traces and 10.4 and 2 inch traces on the differential pairs. And we use an Enritsu model VNA to do the testing. And we did a range from 100 megahertz all the way up to 40 gigahertz using a coaxial K type of cables for the material. I've kind of squished this down so that the 1.2 dB per inch loss value is equal to that. So it's a little bit different scale. They went up to 1.4 here, and you can see the differential traces, like for the 5.3, you can see that the loss is actually a little bit lower than the single-ended. And for the high-speed digital products, we actually see this to be the case, is that your differential loss is going to be a little bit lower. And this happens primarily because if you're using more tightly coupled differential pairs, you're going to see more resin in between the pairs versus broad, the wider spacing between the differential pairs. So that's something to keep in mind when you're doing your design. As far as copper is concerned, I mentioned we use 2 different types of copper in the previous slide. Isola has done testing on 30+ different types of copper across our high-end materials like TerraGreen 400G and Tachyon 100G. This testing was done on Tachyon 100G when tested several different copper suppliers. There was 3 of them in this case, and you can see vendor 2, we did 3 different types of copper from them, and you can see how those copper performance levels vary. The thing about this is these copper vendors, these are all compared to our standard VLP2 copper, right? So this is a % delta of the loss of those coppers. So you can see when you test the coppers, they might say they're all the same roughness, but in reality, just because they might have the same roughness, their topography of that copper has a huge impact on the loss of the copper. The other piece to keep in mind is that copper roughness varies along the roll. Just something to keep in mind, because the copper has a range of roughness as you produce the copper foil in the treatment process. So this is an HDI sequential lamination stack-up simulation that we did. It's basically a 4-layer design. And the purpose of this was really to say what happens to the material properties as we put this material through 10x simulation, right? So what happens to the TG? What happens to the T260s and T288s? What happens when we reflow it up to 20x on this design? And so we did that. We see that the TGs don't change, both DSE and TMA. We don't see that the T260s change or that the T288s are degraded. And we tested this at 260 degrees up to 20x and didn't see any kind of blistering or any problems along there. So we see that the thermal properties are maintained. We see that the electrical properties are maintained. We see that the oxide bond is not degraded. So the resin system, in conclusion, is super stable, and we can handle the material can handle the repeated lamination cycles. We've also had customers that use the material and do the OM testing. OM testing takes a D-type coupon, and this is a stack up. This was run by the TTM group in the Anaheim facility, but for Raytheon. And this was a 4 + 10 + 4 design. And this design made you're supposed to pass 6 cycles and doing a 35 to 230 process, but this passed all the way up to 24 cycles, which is pretty excellent performance. This is the statistical results. You can see each of the coupons that were tested here. Red is going to indicate a failure. Blue is going to indicate that the item was suspended because of some problem with the test. And you can see really there's no failures. Everything looks perfectly fine on this particular set of data. So for the test summary, no degradation was found. No thermal or electrical parameter that was measured was out of range. So both thermal and electrical properties are very stable. Oxide bond, again, not degraded. The resin system is very stable, and repeated lamination cycles are not a problem. The extended OEM and IST testing cycles have no problems either. So it's really consistent. It's got good overall performance compared to pure products, right? And as far as the MRT, remember we talked about the MRT 7+ that we use. This is an older version. We tested, when we qualified this material, we tested both a high resin content, a low resin content stack up. It's a 20-layer design using 1 ounce copper. It's a pretty standard design developed by the HDP user group here in the US. Nokia Joe Smetana is one of the main guys on that. This particular product, you can see the results, all very good results, all passing the IST testing, the ATC thermal cycling testing. Has low CTE percentage on a PCB. Even the unclad is fairly low, but that's 130 mils of just pure resin on that particular coupon. As far as the images I promised, you can see that the holes are very smooth. There's not a lot of gouging or fiber pullout or any of that for that matter. Along those whole walls, there's no crazing, there's no white glass, I guess is what you could call it, because the drilling of this material is fairly easy. It doesn't need a lot of special care per se to make this look great. As far as the IST data, here is some data here on the 0.8 millimeter pitch coupon. You can see the sense data here. This product passed 1,000 cycles without a problem. We've run this product up to 2,000 cycles in the past as well. I just didn't have the data in this particular presentation. As far as CAF performance is concerned, I mentioned that that we had done both 16 and 20 mil. This is the 20 mil showing the 6x reflow, 10x reflow, and as is coupons. You can see over here, we did have 1 coupon drop out. I don't remember what the analysis was on that. But 600 is really where IBM, 500 for MRT 6 or 7 applications. The glass used on this was 2116 and 1078. It's a 100-volt test, 6587 for the parameters. So again, cap performance is great. We've tested this material with various PCB fabricators, and once we get the process in place for them to be able to fabricate, the cap testing is pretty commonly uneventful. So product summary, and here's the end of the whole presentation. I apologize for the glitch there. This product's really engineered to improve the insertion loss on most demanding high-speed digital applications. We have a partner that we work with called Wild River Technologies. He shared with me recently that he's developed a 70 gigahertz platform that they use to help customers speed their designs. And he shared with me a plus or minus 1 ohm impedance result that he got out of his platform. So Tachyon 100G is one of his favorite materials to use on high-speed applications at high frequencies. As far as the applications are concerned, as far as 40 gigabits and above, all kinds of different applications, as we talked about early on. Optimized constructions for calf resistance and lead-free assembly performance. And we have a complete line of laminate and prepregs from 2 to 20 and prepregs from about 2 mils to 5 mils for your stack ups. They're all spread glass weaves so that you can minimize your micro decay effects and mitigate your skew problems. If you use a 2-ply, you're going to get a best skew possible. So if you use something like a 2-ply 1035 glass, you're going to end up with very good skew performance and be able to meet a lot of that requirement there. I know that the 224 gigabits per second is going to require almost zero skew, preferably. There's some things that we're working on right now to mitigate skew, and we'll bring those out on other products in the future. Hybrid compatible, so this gives you a lot of flexibility with the other Isola products, so that you can just use, say, for example, 370HR for a hybrid stack up to reduce cost, or for an RF microwave application using Tachyon 100G for the RF portion of the board. You can use a consolidated press cycle, which saves time in the shop. It's a short cure lamination cycle, so because of that, you can put it in any FR4 cycle and cure it pretty readily without a problem. It's proven in space, phased array applications, radar systems, communications. Communications would be secure communications for mil-aero types of applications, high-end computing applications. And as far as the overall product support, we have global technical and application support with seasoned industry PCB fabricating experts. I work with a lady we just brought on to Isola, who has about 17 years of PCB fabrication and design review experience. We have another gentleman named Michael McMaster. That's Laura Martin. Michael McMaster, who has been at Merrick's TTM, Merrick's Via Systems TTM, Intel, and APCT before he came to Isola, who has roughly 35 years experience. And then Doug Trobaugh, who's our VP of applications, who's got 38 years, I think, in PCB fabrication and materials development, materials applications, and so forth. And so any of these demands, if you have questions about the product and how that would fit into your application, we have lots of expertise at Isola. We are happy to share that expertise with you and with our partner, Epic, and so that you can get your design developed quickly and get it through their PCB fabrication shop quickly. Again, we have global production site capability. I think we're the only true global manufacturing partner where we have manufacturing and fabrication facilities in Europe, America, and North America and Asia. And that is all I have for everybody. I want to thank you for your time, and I apologize for the glitch mid-presentation. Again, thank you so much for joining, and I hope that you find this information very useful. Please feel free to send notes in the chat or email the Epic team, and we will get you answers for any of those questions that you have. So thank you very much, and have an awesome day.